Before we begin looking at these next few problems, let's talk a little bit about discontinuity and where it occurs. If you have a zero denominator, that's undefined. So any value that makes a zero denominator will result in a discontinuity in your graph, in the function. The second place is the square root of a negative. The square root of a negative is not a real number. So if you have a number in a square root that makes a negative, that would also be a discontinuous place of the function. And the graph would not exist for those values, same as with zero denominator. The third place is when you have 0 or a negative in a logarithm. You cannot take the logarithm of 0 or the logarithm of a negative number because they do not exist. So as you're working through this next series of problems, you're going to look for these three situations because that's where your discontinuities are going to appear. So example 24, find all values x equals a where the function is discontinuous. For each value of x, give the limit of the function as x approaches a. Be sure to note when the limit doesn't exist. Well, if we're going to look at this function, we need to use factoring to make it much easier to work with. And the first thing we need to note, though, is that x can never be 6. The reason for that is it would cause a zero denominator. So this is going to be your point of discontinuity. And then to further deal with this, what we want to do is factor it. This will help us actually find the limit. And this is the difference of squares. And the difference of squares, a squared minus b squared, when the first number can be broken down into two identical factors, and the second number can be broken down into two identical factors, and this is subtraction. Okay, this doesn't work if it's a plus. It only works for subtraction. You take one of each of the factors with a plus and the other two with a minus. And so because x squared is x times x and 36 is 6 times 6, this will be one with a plus and one with a minus. And notice the order of the signs does not matter. Now I'm going to divide this by x minus 6. And now I can see the two factors that are identical that divide to 1, leaving me with a much simpler expression for my function x plus 6. So the point of discontinuity is at x equals 6, and they want us to give the limit as x approaches this point of discontinuity, and we're going to do that of our function x plus 6. If we don't reduce it, we would have to do something like 5.999 and 6.001. This is much easier because this is simply 6 plus 6, which is 12. And our limit is going to exist everywhere except at 6. The function is continuous everywhere except at 6. So let's see, which one of these choices is discontinuous at a single value, and the limit is, that's going to work right there. We only have one point of discontinuity, that's a 6, and we found our limit to be 12 at that value. Example 25. Find all values x equals a where the function is discontinuous For each value of x, give the limit of the function as x approaches a. Be sure to note when the limit doesn't exist. Now, if we look back to our three situations where discontinuities occur, zero denominator, square root of a negative, and a zero or negative in a logarithm, we'll notice that for this function, we don't have any denominators, so no denominators, and no square roots, and no logarithms. So that means for us, there is no discontinuity. And that is going to be true for any function that's a polynomial function. So these three situations don't exist, therefore we have no discontinuities. That means it's continuous from negative infinity to positive infinity. In other words, I can substitute any value for x into this function and I will get a real number result. So we're going to find the one that says it's continuous for all values of x. Since there's no point of discontinuity, we don't have to find a limit in this case. The limit at any x value is simply going to be the value of the function. So this one is going to be the limit as x approaches a of f of a is always going to be whatever f of a is, because there's no place to have a discontinuity. Number 26. Find all values x equals a where the function is discontinuous. For each value of x, give the limit of the function as x approaches. Be sure to note when the limit doesn't exist. And my function is k of x equals 3e to the square root of x minus 9. So this is a different kind of function. You may have never seen something like this, but all we need to focus on is whether we have a denominator or a square root or a logarithm. And in this case, we have a square root. So for any square root function, we have to take the radicand, that's the expression inside, and say that it's greater than or equal to 0. It's equal to 0 because you can take the square root of 0. The square root of 0 is simply 0. You just can't take the square root of a negative. That's the one that gets us in trouble. So what I'm going to do is I'm going to take my radicand, make it greater than or equal to 0. I'm going to add 9 to both sides, so x is greater than or equal to 9. Now, that's all the numbers from 9 to infinity where it is continuous. Okay, so that means on this side, it's going to be discontinuous. And what are those numbers? Well, those are the values from negative infinity to 9, not including 9. So this function is discontinuous where it's not continuous, okay? So we found where it was continuous first so that we could say where it's not. So it's discontinuous on an interval, okay? So it's discontinuous on the interval. So f is discontinuous on the interval. And the limit is not going to exist over here because the function doesn't exist over there. So we're going, remember they said find the limit where it's discontinuous, okay? Find the limit of the function as it approaches a, where a is those values where it's discontinuous. So ours is going to have that it doesn't have a limit at all. So looking down at our choices, it's not a single value, it's not two values, it's an interval with no limit. So f is discontinuous on the interval from negative infinity to 9, and the limit does not exist for those values.